Assalamu alaikum, my dear friends. Hoping that you are all fine with the blessings of Almighty Allah. So, right now, what I'm going to do, right now, I'm solving with you some parts like journal and thermal physics of this paper, which is May June 2023, paper 4, variant 2. And as it is, because we are IGCSE extended physics, we are taking, so time allowed is 75 minutes, and the marks which are allocated for this all, they are 80. So for 80 marks in this exam we have 75 minutes. So the thing which is very important to be known or to be considered, that is, it is less than per minute per mark. Okay, then another thing I will keep on repeating that value of g no more nor 10, we will be using acceleration due to gravity g, that is equal to 9.8 meters per second square. So this is paper 4, variant 2, May June 2023, and and we will be discussing block-wise. Like, first of all, we are going to discuss the general physics, then thermal physics, and so on this way. So let's start our proceedings, and we will start from the first question. And let's start. This is figure 1.1, shows helicopter which is stationary. It means the helicopter is at rest. Stationary means initial velocity is at 0 at a height of 1500 meters above the ground. So the graph is drawn there, and helicopter is shown. State two conditions necessary for the helicopter to remain in equilibrium. One condition is, okay, when we are saying equilibrium, it means the acceleration of the body is 0. So either the body is at rest or it is moving with uniform velocity. So in both the cases, the body will be considered to be in equilibrium. Two conditions are there. Resultant force on the object, in this case on the helicopter, should be 0. And condition number 2, resultant moment of force on the helicopter should also be 0. These are the two answers for 2 marks. But I will be writing, because when we are solving numerical problems, resultant force is equal to 0 can also be written like this: total upward force is equal to total downward force. Force is a vector quantity, so if total upward force is equal to total downward force, so the resultant force of these two will be equal to 0. So it's okay, either you can write resultant force equal to 0, but I have written this one intentionally because total, in most of the numerical problems, either we are solving paper 2 or we are solving paper 6. So we are getting a lot of help by using this way of representing resultant force is equal to 0. Now second condition is resultant moment of force is equal to 0, but it will be much better if we can write total clockwise movement. So I'm using just alphabets as abbreviation. Total CWM stands for clockwise movement is equal to total anti-clockwise movement. So in this way you can score these 2 marks easily. Then the mass of the helicopter is 3200 kilograms. So mass is given. Calculate the change in the gravitational potential energy of the helicopter as it rises from the ground to 1500 meter height. So we need to calculate gravitational potential energy. So equation for gravitational potential energy, EP is equal to mgh. Height is given and g is constant on the surface of earth. So mass is 3200, g is 9.8, and height is 1500. So as we are calculating it, so it is 3200 times 9.8 times 1500, it is 47040000. So 47040, then again 3 zeros. We cannot write this much long answer, so simply we can write in standard form 4.7 times 10 raised to power also 7, but don't forget to write the unit, which is joules. So change in gravitational potential energy will be equal to joules. I'm sure there will be no problem here. So let's move forward. Let's proceed forward. Yes, this is a bit tricky. So figure 1.2 shows a vertical speed time graph for a parachutist who jumps from a stationary hot air balloon. Stationary balloon, it means balloon is at rest, it is in equilibrium. So graph is in front of us, and this is, by the way, a speed time graph. The parachutist jumps from the balloon at t is equal to 0. Here he jumps at this point, reaches the ground at B. The point A indicates when the parachute opens. Here, after this point, always here the parachute opens here. And my dear friends, always remember, what is the purpose of this parachute? The purpose of this parachute is to land on the ground safely, mean with smaller speed, which is to safely land on ground with some very small magnitude of speed. So when parachute is opened, basically it behaves like you have applied the brakes to a car. A car was moving at high speed, and as we are applying the brakes to the car, so its speed will be decreasing and ultimately it will come to rest. So whenever parachute is opened, it is causing deceleration, and you can check the negative gradient of the graph just after A shows that there is a deceleration. So anyhow, on figure 1.2, label a point on the graph where the acceleration is 0 with 1. No, acceleration is 0 when the rate of change of velocity is 0. You can check here the graph is horizontal. This can be 1, and here also graph is horizontal. This can also be 1, but only one place we have to mention. So just before A, when it is falling with constant velocity, we will not say constant speed. Constant speed may be a changing direction. So like a car is taking a turn at constant speed, it is still accelerating because speed is constant, but velocity is not constant because velocity is a vector quantity. So as the direction is changing, so velocity is changing, which leads towards acceleration. So constant velocity just before A. Then negative acceleration with 2. So all these points are negative acceleration from here till here, you can say, but let it be this one. And then decreasing acceleration with 3. Up to here in the beginning, see, graph is straight line. So if the straight line graph slope with a slope or incline, so that is gradient of speed time graph is acceleration. Here it becomes 0. So in between this all, see, slope is decreasing, so you can say that acceleration is decreasing. So by labeling in this way these 3 points, we can score all 3 marks. If there is any doubt, please feel free to ask me. Now, explain in terms of forces. In terms of forces, very important. And what are the forces which are acting on a body when it is in air? 2 forces are there. One is the weight, which is the pull of gravity, and weight within the gravitational field close to the surface of Earth, it's constant, it doesn't change. And the other force which is acting on the body, that is air resistance, which changes as the speed of the body changes, which changes as the area of cross section exposed to air changes. So air resistance is directly proportional to speed of the body. Greater the speed of the body, greater will be the air resistance acting on the body, and vice versa. Similarly, greater the area exposed to the air of a body, so greater will be the air resistance. Now let's see here what is the question. So explain in terms of forces the changes in motion which occur from when the parachutist leaves the hot air balloon until the point A. Now as parachutist is mentioned, so mostly students are mentioning in their answer that When he opens the parachute, after some time, weight is balanced by air resistance and it falls with constant velocity. My dear friends, in this case particularly, until point A, it means up to here. We have to discuss all of this just up to point A, not after point A when the parachute is opened. So first of all, in terms of forces, we need to name the forces and their directions. Weight downwards, weight downwards, and weight downwards and air resistance. Air resistance is a type of force of friction. It always in a direction opposite to the direction of motion. So air resistance, further in the question I will be using by AR, denoting it by AR. Air resistance upwards are the forces on the parachutist. So this, first of all, we have talked about the forces which are possible to act on the, which are actually acting on the parachutist. Then in the beginning you can see the graph is a straight line. It means the acceleration is constant. Air resistance is negligible because body just started to move, so speed is negligible. So air resistance negligible. The only force acting is weight, or the resultant force which is acting on the body, that is simply weight. So it falls with constant acceleration. Even you can see acceleration due to gravity because of the force of gravity. Don't say only gravity, either force of gravity or you can say weight. So now for the next mark, I will be choosing another color so that it is differentiating. We can say initially parachutist falls with constant acceleration, due to weight, which is force of gravity. This is second mark. Now another point, as it is accelerating, so it means its speed is increasing. So as the speed of parachutist increases, A dot R, air resistance on it also increases. Air resistance on it also increases. So resultant force on parachutist decreases, and it falls with decreasing acceleration. So this is the third mark. See, initially constant acceleration, now here this portion decreasing acceleration. And the final is, now when weight W is equal to air resistance, then resultant force RF is equal to 0, and acceleration of the parachutist is also what? 0. So in this way you can score 4 marks, and 3 different colors I have used to explain each and every mark. If there is any question or doubt in your mind, please feel free. You people can ask me now. Okay. Now the next question is, a student catches a cricket ball. The speed of the ball immediately before it is caught is 18 meters per second. So initial speed is u, that is 18 meters per second. The mass of the cricket ball is 160 gram. It will not work. So now it is 0.160 kilogram. Why kilogram? Because we need to use system international units when the speed is given in meter per second. So we cannot use mass in grams, it must be kilogram, which is also system international unit. Calculate the kinetic energy stored in the cricket ball immediately before it is caught. So kinetic energy EK, that is equal to 1 over 2 mv square. So 1 over 2 times mass, which is 0.160 times v, 18 square. Don't forget to square this speed. As we simplify, I know because I did it, 925.92 is the answer. So we can write either 25.9 or the better is we should write 26, and the unit for any type of energy including kinetic energy, it is joules, capital J, but we will be using for the unit of energy. Now it was very simple, by the way. It takes 0.12 seconds to catch the ball and bring it to the rest. So now it means its final velocity is 0. Calculate the average force exerted on the ball. For this purpose, Newton's second law of motion, F is equal to ma. M is the mass, which is already given 0.16 a. We can also write it this way. Acceleration is v minus u over t. So 0.16 is the mass, v is 0, u is 18, and t is 0.12. v is 0 here, u is given 18, and time is given 0.12 seconds. So as we simplify it, we are getting the answer equal to minus 24 Newton, and it's okay. Why minus? Because this force is bringing the object to rest. This is a retarding force. This is a retarding force, a force which is causing retardation, deceleration like this. But when you are writing the answer here, so it is better that you should write simply 24 Newton. Please, my dear friends, if any one of you is having any question here, any query here, please feel free. You people can ask me now. Okay. Now, as the student catches the ball, she moves her hands backwards. She moves her hands backward. Explain the effect of this action on student's hand. When she will moves her hands backward, it will increase the time of contact between the hand and the ball. So when the time of contact is increased, the force acting on the hand will be decreased, or there will be less hurt, or her hand will be less hurt, because momentum is conserved. So force times time is equal to change in momentum. So change in momentum is conserved, staying same. So when the time of contact is more, so force exerted is less. Its examples many we can give. If somebody is kicking the football and he is kicking a wall, so he will be hurt a lot when he is kicking the wall. The reason is the time of contact between the foot and the wall is very short, whereas time of contact between the foot and the football is more, because football is an elastic object. So when you kick the football, so football is compressed inwards, so the time of contact, or your toe is in contact with the football for longer time. So when the time of contact will be increased, force will be decreased. Same is the concept of the safety in the cars, like these seat belts or the airbags. As a result of some crash or an accident, severe accident, the airbags of a car are inflated. So what happens? You move forward, but those airbags, when they come in contact with you, so they are compressed a bit. So your time of contact is increased and you are less hurt by that accident. Same is the case with the seat belt. What the seat belt is doing, if somebody is not wearing seat belt and he has to apply the brakes, so what is going to happen, that he will be or she will be quickly moving forward to hit the windscreen or the dashboard, but time will be very short. But if seat belt is being used, so seat belt will increase the time of impact or contact, so force will be exerted less and you are safe. Less injuries or no injuries, or in other words, less force is exerted. Now it is only 1 mark, so not that much detail, so you will write here it increases the time of contact and less force is exerted. That's enough. So in this way we can answer this question. To share with you people with ease, I will be stopping this recording, and then for the next question we will restart the recording. Stay blessed, my dear friends.